Welcome to my channel Esteems Tech. In this video, we are going to learn about lemmatization. I bet you this is very interesting and easy. Come, let's learn together. What is lemmatization? Lemmatization is used to reduce text redundancy by converting words having the same meaning but different inflected forms to their base form. The output we will get after lemmatization is called lemma, which is a root word rather than a root stem. For example, if you lemmatize the word caring, it would return care. Here we have a question that is divided into five parts. Import the word netlematizer class from nltk.stem, then create a list alpha only that contains alphabetical words only as tokens. You can use the isAlpha method to check for this. Create another list called no stops consisting of words from alpha only. Initialize a WordNet lematizer object in WordNet lematizer and use its lematize method on the tokens in no stops to create a new list called lemmatized. Create a new counter called bow with the lemmatized words. Lastly, print the 10 most common tokens. So you can hold for a while and you can try this question on your own. And here is a solution. Right, first of all, we have imported WordNet lematizer from nltk.stem, right? That we are going to use it in this question. Now we have a variable alpha only. So now here you can see here we are using list comprehension. T for T in word tokenize. And within the parenthesis as an argument, we are passing article.lower. So article that we discussed in previous video is an article that consists of 2 3 paragraphs from Wikipedia about Canada, right? So first of all, alpha only is a variable that contains tokenized words. You can see here I have tokenized all the words from article and I converted them to lowercase, and now T will contain these word tokens one by one as the loop executes. Then we have a condition if t dot is alpha. So is alpha is a method that will check, that will return true if t has all the alphabets in the word. So if the word consists of all the alphabets or all the characters, in that case only it is going to return to true. If a word consists of all alphabets, one by one these will be taken in t, right? And then this is the alpha only variable that contains the token that are alphabets only. I mean, the words which are only alphabets, right? I hope I made my point clear. So, alpha only is a variable that consists of tokens from the word from this article about Canada, and all the tokens are in lowercase and all the tokens are consist of alphabets, right? So remove all stop words. Now we have a variable no stops. So see what we are doing here. T for T in alpha only. So alpha only consists of tokens that are in lowercase and are all alphabets, no numeric value, right? So for T in alpha only, now the condition is if T not in stop words dot words English. So here is a condition if the tokens in alpha only are not in stop words, only those tokens will be stored, will be assigned to no stops, right? So there should not be any kind of stop word here, right? So next, see here what we're doing is instantiate the word net lematizer. Word net lematizer equals word net lematizer. So here this is a variable that consists of word net lematizer class. So here we are instantiating it. Then lematize all tokens to a new list. Lemmatized is a list. Now see here again we are using List comprehension. WordNet Lemmatizer dot lemmatize. So lemmatize is a method which is inside WordNet Lemmatizer class. So WordNet Lemmatizer dot lemmatize, and as an argument we are passing here t. T are tokens without any stop word. They doesn't contain any kind of stop words, right? So no stops, or T is T are tokens that doesn't contain stop word. In other words, right? So for T in no stops, right? So here we are using a loop for T in no stops, and all the tokens we are passing it here, we are lemmatizing them, right? The tokens are there, and then without any stop words, and then here what we are doing is we are lemmatizing them, right? Remember the word caring converted to care, that is a root word, so that is lemmatizing, right? So here we are lemmatizing it, then bow equals counter and then lemmatized, right? So counter is a class that you'll have to import, right? So bow contains counter dot lemmatize, means it is going to convert the tokens which are converted to lemmatized form, which are converted to form. So now what we are doing is we are simply counting those lemmatized words. Then here we are printing most common, like 10 most common lemmatized words or root words, we can say. So Canada's root word is Canada, country, then word, United State, North, province, three, ocean, international, right? So this is the output. And from here again, we can just check that the article is about Canada, right? Like, share, and subscribe. And don't forget to hit the bell icon. We are so thankful that you are supporting us.